The time of the speech would be 5 to 7 minutes.
Thank you, Madam Toastmaster, fellow Toastmasters, and our guests. I first got introduced to LED lights as an electronics technician in the United States Navy before I was Navy SEAL. Then I worked for DX2 Broadcasts, marketing their video wall technologies up in Dallas, Texas. And I found that there was more of a demand for commercial lighting, so I switched to LED City. I did estimating for them up in Dallas until I came down to the Rio Grande Valley, and I noticed that there was opportunity. There was a lot of places they did not have LED lighting, so I came down and I started Valley LED Solutions. And I'm going to try to explain to you how LED lights work. LED stands for light emitting diode. Diode is an electrical component that directs the flow of current in a circuit. Electricity goes from negative to positive. In this diagram I got from the Department of Energy website, it shows a diode, and it's positive electrons going to negative electrons going to positive holes. There's N-type material and P-type material, and in a diode or an LED light, they have silicone in between into the depletion zone. What that means is when the energy from that negative electron is excess of what the hole can take, it has to release it, and that is called a photon. And that's what creates the light in an LED light. Now, there is no material that's has negative material or positive holes. There isn't anything. What they do is how the circuit is set up. In this diagram, you'll notice that there's a battery with a positive terminal and a negative terminal, and the N-type material, the negative side, the electrons are going to the positive terminal on the battery, and the positive are going to the negative terminal on the battery, and they're not going through the depletion zone. This wouldn't work. To make this circuit work, you would have to turn that diode around, and that would force the negative electrons to go across the silicon and depletion zone and create the light. And they do that with resistors and transistors and logic circuits. One of the things that makes LED lights unique is that they can change color. And there's two different kinds of color changing LEDs. There's the DIP, which stands for dual inline process, and then there's SMD, which stands for surface mounted diode. Then there's a driver. Now, fluorescent lights and metal halides and sodium vapor, they need a ballast. A ballast is a capacitor which has to build up enough charge to stimulate the light to make it work. And it takes 25 to 50% of the energy usage in a fixture is going to go to the ballast. LED does not need a ballast. They're direct voltage, but they need a driver. What a driver is inductors, transistors, and diodes that take alternating current and make it direct current. And it also steps down the voltage so it will not burn up the LED light. This is kind of gives you an idea. There'll be, red, green, blue, or white. So the RGB or RGBW is how they're designated. The frequency of electricity that goes to the lamp will determine what color it's going to be, which one it's going to activate. For a DIP chip. For an SMD chip, it's one chip, and the color spectrum depends on what frequency is going. The lesser frequency is going to be blue, and the higher frequency is going to be red or purple. In a digital sign, you can see the difference. The DIP is going to have the three different, red, green, blue diodes, and depends on how. And when you get close enough, you can see it with the naked eye. They are getting smaller and getting better resolution. And the SMD is going to be greater resolution, almost like a big TV. You're very clear. You could hardly even make out the chips in it. When it comes to stage and entertainment lighting, these are fascinating pictures. They'll be different color changing. They'll call them universes. There'll be like 20 universes with 150 different channels, and there'll be different colors, different frequencies of colors, strobing, fading, all of that. And I can give a whole class on that, but that's what they do, and they're fascinating. The majority of LED lights components are manufactured in China. It's called OEM, which means other electrical manufacturers. And you have to watch them because they're really conservative. This is an RGB floodlight from LED City, and it's not working. It was just working. If you bought one of these online directly from China, this deflector plate has 4 screws. If you open it up and you found you only had 3 screws, you got a bonus. They cut corners every chance that they get. And so that's why the manufacturers have to have somebody over there. LED City is a father and son team. The father's an engineer. He goes over there every month. He's over their shoulder making sure that all the lights are fitting together the way they're supposed to be. Cree LED is out of North Carolina. They make their chips in North Carolina. They take the silicone, they melt it, and they spread it out like cookie dough, and they cut their chips out different sizes and dimensions and shapes that they need for their fixtures. But then they send them to China to get assembled. This technology is changing so fast. In 2014, LED City was one of the first ones to come out with the smart tubes. And they were $24 a tube, but at Lowe's and Home Depot, they were $28 a tube. Now you can get it for less than $5. And then they're even obsolete. You got the LED strips, which you can just put in the fixture. You don't have to bypass the valves or anything. And then there's the grow lights. Grow lights are used mostly, I think, for marijuana growing, but there's also called hydroponics. Hydroponics is growing indoors using water, and you can produce 10 times more than regular farming with hydroponics, but they need the right kind of light, and you can get that with LED. This is my company information. If you have any further questions, you can go ahead and give me a call, or I can talk to you, do an assessment for your business or whatever. This is a fixture, Election 300, that I sold to Royal Freight a year ago, and they ended up liking it so much they bought 20 more from me, and we just looked at their electric bill. They saved an average of over $400 a month, and it only cost them $13,000. They've already paid for their fixtures. That's one of the other big benefits of LED lights is energy savings. Thank you very much.